Hello, everyone. Welcome to this talk. My name is Otieno. I'm a software engineer at Teya. And today we're sharing something a bit nuanced, best practices for federated GraphQL and lessons we've learned at Teya over time. So I'll start off with a quote by one of our most famous philosophers. Says, "The whole is greater than the sum of its parts." This quote by Aristotle aligns well with the theme that we've built over time at Teya, basically, and also kind of like captures the spirit and the principle that we were using when we were federating our graph from monolith to federation. So it kind of like emphasizes the idea that when small and self-contained parts, which are services in this case, are brought together in a consolidated way, or coordinated or interconnected manner, this is like the GraphQL, the resulting whole becomes more powerful and effective. So it mirrors the benefits of schema decomposition and schema federation in increasing scalability, that's one, and modular architecture. So, well, Aristotle is the author of this quote. It's a timeless concept that holds relevance in various contexts, including software architecture. BFF monoliths. We all start from somewhere, and our journey is no different at Teya. While monoliths represent like a unique approach to software architecture, where custom API is meticulously crafted for each front-end application, the normal stuff, offering fine-tuned like control and optimization. Brings us to something that we all started off with. So at Teya, we had front-end teams that were basically starting off with GraphQL. This was a couple of years ago. And as you can see, this was before federation, and we had some multiple backend for frontends. The microservices in this case represents like the data sources that we had, and the clients were various clients that we were serving. So we had the business portal, which in this case were the merchants that we were serving, the client-facing merchants, and then we have the internal teams. All of them have been represented as clients in this diagram. So we noticed something with this. While it was solving the problem at hand, we noticed there was a bit of overlapping. And also there were some challenges that I might want to not delve into today, because that's not the purpose of this talk. But this was going on for some time. And so what was wrong with it, basically? There were some challenges, of course, as I've mentioned. We noticed like custom APIs, which is BFF in this case, each front-end introduced like a complexity and increased development and maintenance overhead with time. And so the complexity, there was like numerous scalability issues when managing multiple BFFs for different front-ends, as you've seen. Balancing server resources among these BFFs with varying performance requests proved overtly complex, I would say. So we risk having poorly optimized GraphQL queries, and that at times strained server resources, impacting overall scalability. So as front-end requirements evolved, maintaining multiple BFFs became a burden for us. Adapting BFF to changes in front-end apps was time-consuming as well. And managing GraphQL schema changes versioning and ensuring backward compatibility was a complex ordeal. So while BFF, as you all know, monoliths have its own merits, okay, some of us will agree, it was crucial for us to understand like the complexities, scalability concerns, and maintenance challenges they introduced to teams. They are like different teams that were all had like their own BFFs. So by doing so, we were better equipped to navigate this landscape wisely. So what was our solution? Well, essentially, we did recognize that every challenge comes with an opportunity to innovate and improve. That was always our motto. The whole is greater than the sum of its parts. So a case for the Federation presented us with the idea of if we incorporated this ancient quote to mirror the essence of our journey with Federation, emphasizing how by orchestrating individual services in data sources in coordinated and interconnected manner, we create like a system that was more powerful and effective as a whole. Enter Federation. So we had like a single source of truth. I know by now we've all heard what Federation is, what it does. Basically just that. For us, this made us work fast as a team, and also ensured that while we are still on the journey for Federation, we could be able to manage most of the clients' requests or demands in a very short period of time. We won't delve much into Federation per se, but we are going to really delve on how the best practices we can use to ensure that we approach the Federation journey in a more battle-tested and efficient way. So why Federation for us? So we continue the journey. As we continue our journey through the world of GraphQL architecture, it's natural to ask, why Federation? Why should we approach or embrace this approach in general? Well, to answer this question, really, we need to explore the myriad benefits of Federation, what it brings to the table. Number one is modularity that comes to mind. Federation introduces a powerful advantage, which is modularity. So this means breaking down GraphQL schema into small self-contained units. Well, this approach, you can develop, test, maintain individual parts separately, which is nice. And you can also try to, it's like assembling a complex puzzle piece at a time, allowing for more efficient development and ensuring that each piece fits seamlessly. Another one was scalability. So this is a cornerstone of modern software architecture, we all know. And Federation, to us, from our experience, offered a solution by enabling improved scalability based on the multiple BFFs that we had. So the beauty of this approach lies in its capacity to manage different parts of our schema independently, which was good in our case. As your application grows, you can distribute the load more efficiently. So this ensures your system can flex and adapt to changes, demands without the need to complete overhaul your solution. The next one was independence. We're talking about free advantages or benefits per se. So Federation is a champion, of independence. It empowers team to work on different parts of the schema independently, promoting team autonomy. So what does this mean generally? Well, this autonomy leads to faster development cycles for various components of your application. It's a harmonious symphony of collaboration, which each section plays its own tune, contributing to the success of the whole. Those who are familiar with classical music understand how orchestra works. So while one instrument might be playing something completely out of tune if it plays in the singularly, it needs other instruments in the orchestra to enrich the sound. So this is how we were viewing our subgraphs. And then we go back to the quote. The whole is greater than the parts of its. That in itself enabled us to ensure that we were going the right direction by clearly having a single source of truth that was a supergraph, and also ensuring that each subgraph was only doing one thing at a time. That was separation of concern. So In conclusion, to all the benefits of federated GraphQL architecture, federation to us was not just an architectural choice, it was a strategic advantage. It encapsulated modularity, scalability, independence, offering an approach that was perfectly aligned with a result of rhythm. The whole is greater than the sum of its parts. So our journey with federation, all of us in this room, I would say has just begun. And we'll continue to explore these benefits that can be leveraged in practice to revolutionize our GraphQL architecture. So, to the main theme of my talk. To harness the full potential of federation, we need to put into practice a set of best practices that will guide us on this journey. Number one is schema design. So structuring your services in a way that ensures each service has its unique definition should be your top priority. You should make sure that each of your dedicated resolvers and individual data sources are aligned to what your clients actually want. You should not be solving for a problem that's not there. So this practice allows for a more organized and efficient system for you and your team to manage. So to enhance the maintainability and scalability of your system, basically, we need to break down our schema into smaller self-contained services. So these services should be designed to represent specific domains or functionalities. So this modular approach simplifies development and maintenance. Furthermore, it's essential to establish boundaries between these services. So by defining these boundaries, we can interpret or prevent data overlap and minimize tight coupling. So this not only enhances the robustness of our system, but also makes it clear and easier to manage and evolve as our project grows. So the part of clear boundaries and ensuring that we have like atomic services, we have some bit of code. So in my theme, in my presentation, we're going to have like two subgraphs. One's going to be user subgraph, the other one's going to be product subgraph. So here you can see the separation of concern plays, it shines in this regard. So we have the product subgraph, and you also have like the user's subgraph, okay? Pure and plain to its own. It's only knowing exactly what it needs to resolve at a given time. So we won't talk about resolvers today, just the schema design at this point. So we are assuming this is a schema-first approach. And our clients basically wants to see, they get a user by ID, list users as well, create, update, and delete user. Basically just a CRUD operation. So let's dive into the concept of supergraph and subgraph. Well, the supergraph serves as a comprehensive schema through which clients interact with our system. It should be an amalgamation of all types of queries, mutation, and relationships stemming from various subgraphs. And the unified schema should provide clients with a holistic view of the available data and operations. So on the other hand, a subgraph should be more specific. So each subgraph should take only ownership of and expose particular types and fields. That's it. So it is these subgraphs that will represent the distinct parts of our system, encapsulating data and functionality related to their respective domains and responsibilities. So as you can see, let me bring back the product subgraph. What if we now want to create a relationship between the products and the user? How can we approach this? So we can try and use the extend keyword of the type user and just resolve for, so this is, we are creating like a stub on the user's type, okay? So where we are only resolving for the products inside of the user, and the external directive basically just says, okay, so this type user, the username, we are assuming, okay, it knows that the supergraph will know that the user exactly is a subgraph entity with a key directive, and it will uniquely identify the user with a username field. The external basically tells it that, okay, so we don't need to define this field here. We are going to, it has been defined somewhere. So it only makes sense for the products to resolve for the products field inside the user, other than having the products field in the user's subgraph. So this creates like a separation of concern and also atomic services, basically. For the users, we can do something similar. So let's say we want users to have ownership, or products to have ownership in this case. So we can use a field, okay, where basically the same thing that we did with the product, we are extending now the product here and stabbing the owner field, where the user's subgraph is going to now resolve for the owner's field inside of the product. And as well, the ID, it's a unique field that will uniquely identify the product. So if we move away from that, we go to gateway layer. So what role should your gateway play in your system? So basically the gateway it must often play a pivotal role in your architecture seamlessly by weaving together schemas derived from various services. It should take advantage of managing federated queries, orchestrating the flow of data across services, and ensuring that efficient resolution of client requests. So the gateway should have a gateway server. That's just the entry point for all your clients. So as you saw with the GraphQL federation diagram that we had, we only had a single entry point where all clients were just calling our gateway. Query planning is also very important because we need to minimize or optimize the plan how federated queries get executed. So through this process, the gateway server gets to ensure that data, okay, retrieval is carried out in the most efficient and effective manner, providing clients with responsive, reliable access to the system's resources. So this is just a TypeScript code where you can just showcasing how you can create your gateway. Okay, nothing much going on. So we have like a server using Apollo server and the gateway there. And down there we're just creating a server using Express. So error handling is also very important. Okay, to ensure that we are in the proximity, because we'll never get it 100%, of achieving a more seamless client-side experience, we can utilize GraphQL error handling to maintain and standardize error formatting that simplifies client-side error management. So this way, in the event of error arising during federated queries or mutation, it's important to propagate the error back to the client. So this will ensure that the error details from various layers of your system are conveyed to the client. And also it allows for more comprehensive understanding of the issue and better decision making on how to handle it. Consistent error formatting across your services is also very important, because consistency in error formatting makes it easier for clients to handle errors uniformly. So don't throw your errors. We can use logging in this case, but this was just an example of how we can try and see how we can handle errors. Okay. Caching and performance. So consider implementing caching and batching at the gateway layer to enhance your systems and alleviate the workload on individual services. So caching enables the storage and retrieval of frequently accessed data, reducing the need for services to repeatedly process the same queries. So as a result, query response time are improved, leading to a more responsive and efficient system. So also you can consider like caching and batching the gateway layer, at the gateway layer basically, to enhance system performance and efficiency. So leverage batching techniques to minimize the quantity of requests sent to individual services. So here we can employ tools such as data loaders from Apollo server to simplify the implementation of these practices. Again, just another example of how you can use data loader. So to ensure comprehensive monitoring and metrics tracing in your GraphQL server, consider integrating specific tools and techniques that will serve you in the long run. And to gain insights and performance on reliability of your GraphQL system, it's essential to monitor various metrics. Utilize tools like Prom Client and library to facilitate Prometheus metrics. As for tracing, basically, in distributed tracing, this is very instrumental in understanding the flow requests for your federated services. So the practice will enable you to identify bottlenecks, troubleshoot performance issues, and ensure a seamless user experience. Again, another small code to see how you can define your custom metrics, also record the query duration, whatever you need to do using middlewares. So this is how you can do it inside of the gateway, and also register metrics to use the middleware, and just expose your Prometheus metrics because and have them be available at any endpoint. In this case, metrics. So in the realm of GraphQL architecture, 3 key practices should stand out. Number 1, we have independent deployment, which is a fundamental principle to deploy services independently. Another one is horizontal scaling, which involves the capability to scale individual services based on their unique resource requirements and performance demands. Another one, which it's not in my slide, is GraphOS. So when it comes to composing the unified schema for clients, a powerful approach is to delegate the composition task to a specialized service or component. Documentation is also very important. We can foster collaboration and understanding among teams using our services documentation. So create a detailed documentation for each individual service, covering each aspect, such as schemas, services schemas, resolvers, and any shared types. So this not only simplifies integration, but also promotes collaboration and efficient utilization of services with other broader GraphQL ecosystem. Versioning is also very important. So it allows you to maintain and support multiple iterations of your services schema simultaneously. Testing is very important as well. So in order to maintain a robustness and reliability of your federated system, it's essential to implement a comprehensive testing strategies. So end-to-end comes into play here, where you are testing federated queries, ensuring that the system functions correctly as a cohesive whole. Integration tests just for thorough validation of your services. So here you're catching issues basically before you get them integrated into the federation. And also, in conclusion, we can recap the main points that you've covered in this presentation. We've explored how adopting a federated approach to GraphQL enables you to build scalable APIs by basically breaking down the system into interconnected services. So we now understand that this approach empowers independent development, optimizes performance, and simplifies maintenance. We've also discussed the benefits of organizing your schema into atomic services, each dedicated to specific domains or functionalities. So this approach enhances modularity, maintainability, and overall system efficiency. While at it, the central role of the gateway in stitching schemas, optimizing query execution, and routing, basically, requests was emphasized in my talk. So I would like to view gateway as a key component in ensuring efficient and responsive data delivery, thereby enhancing and orchestrating queries to optimize performance. So while the highlighted importance of a comprehensive testing strategy was eminent in my talk, end-to-end, that's integration tests and also making sure that we ensure the correctness of our system. We can discuss in broad team-wise the value of monitoring and metrics because it varies from team to team. So just make sure that for tracking performances, error rates and other critical metrics, facilitating like ongoing improvements, you have like an in-team understanding of what to track and what to log, basically. So implementing these best practices in a federated GraphQL is crucial for a robust, scalable, and maintainable system. So it not only streamlines development and enhances performance, but also ensures a more seamless and reliable user experience. Thank you.